Now we start next point, which is about relation, a mathematical relation here. So we take two sets here. We consider two sets. Let's call A and B. Both should be non-empty. Like I have one set here with some members, for example 1, 2, 3. The another set, this is a set A. I have another set, for example B, with let's take member 4, 5, 6, 7. Now I'll connect the members of these two sets like this. For example 1 with 4. Let's take 2 with 6, for example 3 with 7, and 2 again with for example 5. So this is one representation or one diagram that gives us a relation between members of the two sets. So here we can say that 1 is connected with 4, 1 comma 4. 2 is connected with 5, so 2 comma 5. We say related sometimes. 2 connected with 6, so 2 comma 6. And 3 connected with 7, so 3 comma 7. So indirectly, if you look at this, these are the ordered pairs. So we form a set here. So this is called a relation here, relation R. Now to form this set here, you took members of A and B. So sometimes this is called relation from A to B, is called a relation from A to B. It's normally denoted by capital R. So what is a relation? Relation is a set, curly bracket, you recall. Relation is a set whose members are ordered pairs. So in general we say that a relation R is a set. So here relation means set, remember. Relation is a set whose members, you know, set consisting of some members whose members are ordered pairs. Ordered pairs. This is the most general way of defining a relation. What's a relation? When we have the word relation in 11th and 12th, that means immediately we must have this thing in our mind. What? A set. But which type of the set? Whose members are ordered pairs. So this is one example of a relation. Now this is just randomly I have considered. You can consider 1 with 6, 2 with 7, that way. So you can form the many relations. Now indirectly, these are nothing but the members of A cross B, if you recall. What is A cross B? Now you know. It is a set of ordered pairs. Now here you have how many ordered pairs? 3 here and 4 members here. So total you have 12 ordered pairs in A cross B. How many ordered pairs? 12 ordered pairs. Out of 12 ordered pairs of A cross B, I have just chosen 4 randomly. There is nothing special about this. You can select 5, 6 and so on. So now this is more precise definition. You can say that a relation R is any subset of A cross B. What is this? This is just a subset of A cross B. A cross B, you know, it has how many ordered pairs? 12. Out of 12, I have just chosen 4 ordered pairs, 1, 2, 3, 4. So this become a subset. So same way you can find number of subsets, all are called the relations. You will come to know in few minutes how many subsets can be formed. So a relation R is any subset of A cross B, or you can say or a subset of let me call R of A cross B is called a relation from A to B. Is called a relation from A to B. I hope now this is clear to you. Everything is same. This and this one all are same things, remember. Any subset, or subset means any subset R of A cross B is called a relation from A to B. What is A cross B? It is a set of ordered pairs. So if I take a subset of A cross B, it would have also ordered pairs. So you can say that that's what I've written. Relation set are always consisting of what? Ordered pairs. This is more specific definition. Now here, let me take one example. Before I take some examples, relations we usually denote it by this symbol. So relations we denote by R, S, T and so on. Now you may have some ordered pairs in the relation. So if one ordered pair A comma B is a member of the relation set R, implies we say that A related to B. A related to B. They are related through certain relation. A related to B, and we write like this: A, then R, and then B. And reverse is also true. If we have A related to B, then we say that A comma B is in R. So that is, you have this now standard notation: A comma B belongs to R if and only if we write A related to B. This is commonly used symbol here in this chapter. A comma B belongs to R, then we say that A related to B. For example, in this example, you can say that 1 related to 4. So I can write here, for example, 1 related to 4. 2 comma 5 is in R, so I can write 2 related to 5. But you know here, for example, 3 is not related to 6. 3 comma 6 is not there. So we can write like this: 3 is not related to 6. This is just for your information. So let's take an example. I've started with a set having 2 members, and here again 2 members. So you know A cross B will have 4 ordered pairs, you know. Your number of ordered pairs will be 4, you know. 1 4, 1 5, 2 4 and 2 5. That you know. Now what I'll do, I'll take one subset here. Let's take R equals to, for example, I'm taking 1 4 and 1 5. 1 4 1 5. So out of 4 ordered pairs, I've taken just 2. So this is a relation. A relation from where to where? A to B. Relation from A to B. I'm just showing the examples of relations. Why this is a relation from A to B? Because it is a subset of A cross B. One more, suppose I'll take just one ordered pair, 2 comma 4. So this is also a relation. I'll call that as S. Is a relation from A to B. From A to B. This is also a relation from A to B. Suppose I'll take one more, T equals to, I'll take for example 1 with 4, 2 with 5 and 2 with 4. I'll take 3 ordered pairs here. So this is also a relation. Is a relation from A to B. Is a relation from A to B. Is a relation from A to B. You can take one more. Suppose I'll write R dash. I'm taking no members of this, so just 5. So this is called a void relation sometimes. Void relation. I have taken no members from R dash, for example. I have taken no members from the A cross B. So this is also a relation. So this is called void relation. One more. Let me write, for example, again R equals to, I'll take all four ordered pairs, that is A cross B itself. So this is called universal relation. Universal relation. So these are the two special cases. Void relation means relation consisting of no ordered pairs. Universal relation means it consisting of all ordered pairs of A cross B, that is A cross B itself. So these are the two special relations. Now question arises is how many such relations you can form if you are given A and B. Now you recall what is the relation. So the next point is number of relations, total number of relations. Total number of relations. Total number of relations. How many such relations you can form? You can take for example singleton 1 4 also, singleton 1 5 also, and so on. So we want to write the total number of relations. So you recall what is the relation? It is a subset of A cross B. So total number of relations, it is as good as total number of subsets of A cross B, which you know. So let's take set A with for example n elements, and another set B with here let me take m, and here n members. So you have set A with m number of members, here you have set B with n number of members. Here A equals to m, so 2, and n is also 2. So total number of relations equals to total number of subsets. Number of subsets of which set? Subset of A cross B, you know. Any subset of A cross B is called a relation. So total number of relations, it is same as the total number of subsets of A cross B. Now you recall from sets, how do you find the total number of subsets of any set? That is 2 raised to number of elements in that set, that is A cross B. This is from sets. If set A has for example 3 members, then the total number of subsets, if you remember, 2 raised to 3, which is 8. You know this much from sets. So same thing, I repeat this one here. Number of relations from A to B, it is as good as you find the total number of subsets of A cross B. Because what is the relation? It is a subset of A cross B. Any subset of A cross B is called a relation. So number of relations equals to number of subsets of A cross B. Now question arises how we can find the total number of subsets of any set, that is 2 raised to number of elements in that set. So number of elements in A cross B. So if set has, again you recall this, how do you write the number of elements in A cross B? That is m into n. So 2 raised to m into n. So this way we get the formula for the number of relations. So if you come to this example, here A cross B has how many members? 4 members. So how many such relations you can form? In this case, the total number of relations will be, in this case here 1 2 3 4 5 I have listed. How many you can list? That is 2 raised to number of elements in A cross B, which is 4, so 16. So you can form such 16 relations. 5 are shown. One is this, the second one is this, third one is this, fourth one is this, fifth one is this. So how many you can form? That is 16, 2 raised to 4. Right? Using this formula, 2 raised to number of elements in A cross B. A cross B has 4 members, so 2 raised to 4. You may have singleton 1 4, you may have singleton 1 5, you may have 2 5 2 4 and 1 5. That way you list here, you will get the total how many subsets? 2 raised to 4, which is 16, and all are relations from A to B. So let's take P equals to this set, Q equals to this set. So obviously P cross Q would have 4 into 2, that is 8 ordered pairs, that you know. So therefore total number of subsets, total number of relations or subsets, relations from P to Q. Remember, you are writing total number of relations from P to Q, That means you are writing total number of subsets of P cross Q. Now how do you find the total number of subsets? That is 2 raised to number of elements in P cross Q, which is 8. So 2 raised to 8. We know that this is a big number, but that's not important what is value. But this many relations you can list. For example, here one relation, here one, you can take 5. This is subset of P cross Q. This is void relation. Then the second relation you can list R equals to P cross Q itself. P cross Q itself. This is universal relation. Universal relation. Then here, let me write R here. Second, you can write R equals to, for example, here, let me write just one ordered pair, 1 comma A. So is a relation. From where to A? From P to Q. From P to Q. These are also relations from P to Q. And so on. So if you make such a list, you will get the 2 raised to 8 relations. 2 raised to 8 relations. So this is actually a list of 256 relations. A big number, but that's not important. The important one, we have this many subsets of this relation. Okay, that's one thing. Sometimes we, instead of two different sets, we may have a single set. So relation in a set. So here relation R is in a set A, let me call. So relation in a set A means R is a subset of A cross A. Earlier we had A cross B, that is two sets were different. Here both are equal, that's the only difference. So relation R is a subset of A cross B. What's the difference between this one and earlier we discussed? There, for example, you had two different sets, but you may have P and P here. Again, P have 1, 2, 3, 4 members, so that way. So this is also sometimes commonly used word, that a relation in a set. For example, if I take here only one set, let's take 1, 2, 3. Right. Then A cross A would have 9 ordered pairs here. 9 ordered pairs. So you can find a relation R in or on a set A as R equals to, you are in A cross A with 9 ordered pairs. I'm taking some ordered pairs randomly, just 1, 1, 1, 2, 2, 2 and 3, 3, for example. So this is a relation in a set. Relation you can call from A to A or in a set A. Relation R in a set A or on a set A, or it's a relation from A to A to itself. So this way you can consider. This is just a random relation from A to A. That means I have considered one subset of, this is one subset of A cross A instead of A cross B. Earlier we used to do with A cross B. Here we are using A cross A. So now next, domain and range of a relation. So let's take a relation. Let R be a relation from A to B. R be a relation from A to B. So when we say that R be a relation from A to B means what? R is a subset of A cross B. Now that's clear to you, I hope. So R will have ordered pairs. So first we define domain here. Domain of R. It's very simple. It's a set of all ordered pairs which are at the first place. So set of all A such that A comma B belongs to R. This is called domain of the relation R. What you have to do, you collect all ordered pairs you collect all members which are at the first place in the relation, in the each ordered pair of the relation set R. Suppose if you have 1 2, then put 1 here. If you have 3 4, put 3 here. And range of relation R, that is range of relation R equals to all elements which are at the second place. So A comma B belongs to R, then you collect all elements which are at the second place. Here elements which are at the first place, elements which are at the first place, here elements which are at the second place in each ordered pair, of the relation R. For example, I'll take let's take A equals to 2 4 5 for example. B equals to, I'll take -1 2 0. So for a relation R from A to B, R equals to, so now you must realize what I'm going to do. I'm going to consider some ordered pairs out of this 9. Suppose 2 comma -1, 4 comma 2, then 5 comma 0, then 2 comma 0, and let me write 5 comma -1. Suppose I've considered this many ordered pairs, one relation, this is given to you. So what's the domain of the relation here? So domain will be here, domain of R will be all elements which are at the first place. So 2 4 5 2, you cannot repeat 2, and 5 is also there. So this is the domain of the relation. Elements which are at the first place in each ordered pair. So 2 4 5, 2 is, but we already written, 5 already written. So this is the domain. Range of R. So what is the range? All elements which are at the second place. -1 2 0, again we have 0, and -1 is also there. So this is the range. -1 2 0, elements which are at the second place. -1 2 0 0 -1, this is the range. Now sometimes, as I mentioned earlier, you can represent this by drawing such diagram. Here the first set has how many members? 2 4 and 5. Second set has how many members? -1 2 and 0. Set A, set B. Here 7 related to 2 related to -1, so I'll connect 2 with -1. 4 related to 2, so I'll connect 4 with 2. 5 related to 0, so I'll connect 5 with 0. 2 related to 0, so I'll connect 2 with 0. 5 related to -1, so I'll connect 5 with -1. This is sometimes called arrow diagram of the relation. Arrow diagram of the relation, just by putting arrows of the connected members. Let us go to exercise 2.2 now. You are given a set here having 1 to 14 members. Relation R from A to A. That means R will be now subset of A cross A. Remember, it's not relation from A to B. Here it's a relation from A to A. That is B equals to A. By this definition already given to you, all x comma y relation means, you know, set of ordered pairs satisfying this condition. Actually A cross A would have 14 into 14 ordered pairs, but out of those ordered pairs you find for which this condition is true. So you write down its domain and codomain and range. Codomain means second set, which is A itself. So let's see this. So here R is x comma y for which this condition is true. That means y equals to 3x. So what are the members of the relation set R here? Take x equals to 1, so y will be 3. 1 comma 3. If I put 2 here, 2 comma 6. If I put 3 here, 3 comma 9. If I put 4 here, so 4 3 are 12. Now you can xy both comes from a, so I can take 5 also here. But if I take here 5, then y will be 15. But 15 is not there, so you have only this many ordered pairs. This is the relation set R, remember. Now if you recall, you can write like this: 1 related to 3, 2 related to 6, 3 related to 9, 4 related to 12. This way you can write. That's what I'm trying to tell you. 1 related to 3 means 1 comma 3 is in R. 2 related to 6 means 2 comma 6 is in R. This is just for your information. This is a representation of the relation in a roster form. This is, you recall from the set theory, this is a roster form. Here A cross A, you know, here A cross A would have 14 into 14, that is 14 into 14, so 196 ordered pairs. Out of 196 ordered pairs, you have just 4 for which this condition is true. Okay, now domain. What is the domain? All elements which are at the first place. So 1 2 3 4, 1 2 3 4, that's the domain. 1 2 3 4. What's the range? All elements which are at the second place. 3 6 9 12, 3 6 9 12, that's the range. What is codomain? Codomain is the whole second set. If relation is from, for example, A to B, then B is called codomain here. Here it is a relation from A to A, so this become codomain. So codomain is A, that is 1 to 14. Domain means elements which are at the first place in each ordered pair. 1 2 3 4. Range means elements which are at the second place. 3 6 9 12. And codomain means entire second set, that is this A. Now this is not asked, but let me see this. Total number of relations. Total number of relations. You recall the formula. What is total number of relations? That is equals to 2 raised to number of elements in A cross A. Total number of subsets of A cross A. That is 2 raised to number of elements in A cross A. That is 2 raised to A cross A has 196 members. So this is 2 raised to 196. It's very big number, which is not important for us, but this just for your information. This many relations you can form from A to B. Out of this, one is here. Arrow diagram. This is again not asked, I'm just showing you. So you have set A with 14 members, 1 2 3 4 and so on up to 14. You have another set again, A. This is 8 from A to A. So 1 2 3, then somewhere you have 9, then somewhere you have 12, and then you have 14. So you just connect the related elements. 1 with 3, 2 with 6, so somewhere you have 6 here. 3 with 9, so 3 with 9 here, and 4 with 12. This is called arrow diagram of the above relation. So next question is relation R on N. You know N is set of natural numbers, which is an infinite set. Defined in this way: x comma y, where y is equal to x plus y, but x should be less than 4. That is just 1, 2 and 3. Both comes from natural number. So what are the members of the relation set R here? If I take x equals to 1, then y will be 6, 1 plus 5. Next, if I take 2, 2 plus 5, 7. Next, if I take 3 here, so 3 plus 5, which is 8. So we have this many ordered pairs only. X has only 3 possible values, 1, 2 and 3. This is the relation R. What's the domain of this relation? Domain of R is all elements which are at the first place. 1, 2, 3. What is the range of the relation R? Range of R, all elements which are at the second place, which is 6, 6, 7, 8. That is the range of R. Codomain, if you want to write, codomain of R, that is, it's a relation from n to n. On n means it's from n to n. So codomain is entire set of natural numbers. So next, fifth question, you are given a set A with this 1, 2, 3, 4, 5 members and relation R on A. That means it's a relation from A to A. That means R will be subset of A cross A. Now here A cross A would have 25 ordered pairs. Out of 25 ordered pairs, you find all ordered pairs for which this condition is true. B is exactly divisible by A. Exactly divisible by A means this number should be multiple of this. So for example, if this is 2, then this must be like 2, 4, 6, that way. Second number must be multiple of the first one. So here first one, that is R in a roster form. R in roster form. That is, I'll write the members of R. So here if I write R in a roster form, suppose I'll take first member here. A and B both comes from A, obviously. So suppose I've taken 1 here. So here 1 comma 1. Why? Because 1 is divisible by 1. Then 1 comma 2. Why? Because 2 is divisible by 1. Then 1 comma 3 also. 1 comma 4 also, because 4 is divisible by 1. 1 comma 6 also, because 6 is divisible by 1. Then I'll take 2 here. 2 is divisible by 2. You cannot take 2 and 3 because 3 is not divisible by this. So you have 2, 4, and then 2 with 6 because 6 is divisible by 2. Then I'll go to 3. You cannot take 3, 1 because 1 is not divisible by 2. You cannot take 3, 2 also, directly 3, 3. Then 4 is not divisible by 3, so 3, 4 will not come. But 6 is divisible by 3, so 3 comma 6 will be there. 6 is divisible by 3. Then we go to 4 here. With 4, you cannot take 1, you cannot take 2, you cannot take 3. So directly 4 comma 4. You know this. And then with 6, you cannot take this number 6. 1 is not possible because 1 is not divisible by this. So directly you have 6, 6 here. This many ordered pairs will be there in the relation set. So domain of relation are all elements which are at the first place. So 1, 1, 1, so 2, 3, 4 and 6. 1, 2, 3, 4 and 6. 1, then 2, then 3, then 4 and then 6. And third one, range of R, which is elements which are at the second place. So 1, 2, 3, 4, 6. 1, 2, 3, 4 and 6. This 2 is again there, so no need to write here. This is not asked, but total number of relations here. Total number of relations, that is 2 raised to number of elements in A cross A. Now here A has how many members? 5 members. So A cross A will have 25. So 2 raised to 25 relations. It's again very big number, but this many relations, total number of relations you can form from A to A, that is on A. So next, 9th question, relation R on Z, which is set of all integers, which is an infinite set, What's the definition of relation here? A comma B, where A minus B should be an integer. Difference should be an integer, and obviously A and B both will be from Z. So here it's difficult to list all the ordered pairs, but just for your information, R would have such members like 0, 0, because 0 minus 0 is an integer. then you may have 0 1 because 0 minus 1 is also an integer. You can have 1 0 because 1 minus 0 is also an integer. Then you can have 2 0 0 2. Then you can have minus 1 0. Then you can have 0 minus 1. Then you can have minus 1 because difference is 0, which is an, and so on. So there are infinitely many ordered pairs. Usually we never list this, but this is just for information. This is a set. Now what is the domain of this relation? So domain of relation R would be all members which are at the first place. That is, you can have 0, you can have minus 1, you can have 1, you can have 2, you can have minus 2. So you'll get all integers. So indirectly it is again Z. All integers will be there at the first place. And range, same way, range of R. There also you can have 0, you can have 1, you can have minus 1, you can have 2, you can have minus 2, and so on. So which is also Z. So domain of the relation all integers. The range of the relation is also all integers.